Hello friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to discuss electric cells and batteries. A simple device to maintain a steady current in an electric circuit is electrolytic cell or electric cell. It converts chemical energy into electrical energy. This is our simple electric cell. It has two electrodes called positive and negative. Both the electrodes are immersed in an electrolytic solution, and these electrodes exchange charges with the electrolyte. Here our electrolyte is sulfuric acid. Then what about battery? Battery can be made up of one or more cells like this. For example, car batteries contain 6 cells. The common 9-volt battery contains 6 1.5 volt alkaline cell stacked on top of each other. Then why do we use cell or battery in a circuit? When a battery or cell is connected to an electric circuit, electrons flow from negative terminal of the battery to positive terminal through circuit. By using chemical reaction, this battery produces potential difference across its terminals. This potential difference provides energy to move the electron through the circuit. Next one is electromotive force and internal resistance. A source of electrical energy has a characteristic EMF Xi and an internal resistance R. A battery or cell is called the source of electromotive force. Actually, it does not refer a force but describes the potential difference in volts. This symbol is called as Xi. Electromotive force is measured in volts. It is equal to the potential difference across the terminal of the battery when there is no current flows through the circuit. Then how do you define EMF? EMF is nothing but work done per charge to keep the potential difference of a source constant. Or simply we can say potential difference of the source when there is no current flowing through the circuit. That's all about EMF. An ideal battery has zero internal resistance and the potential difference is equal to the EMF of the cell. What is internal resistance? It refers to the opposition of flow of current offered by cells or batteries themselves, resulting in the generation of heat. This is called internal resistance. So ideal battery has zero internal resistance and the potential difference is equal to the EMF of the cell. For a real battery, the potential difference across the terminal is not equal to the EMF of the cell. But a freshly prepared cell has low internal resistance and it increases by aging. Next one is determination of internal resistance. What is internal resistance? It refers to the opposition to the flow of current offered by cells or batteries themselves, resulting in the generation of heat. It is measured in ohms. Consider this as my battery. This is my positive terminal and this is my negative terminal. Battery contains EMF Xi and internal resistance R. EMF Xi and internal resistance R. So this is my battery. If you want to measure the EMF of the cell, you should connect high resistance voltmeter. Now the voltmeter gives the value of EMF of the cell Xi. Here I didn't connect any external load. So this circuit is considered as an open circuit. In this diagram, I connected one external resistance capital R. So current I flows through the circuit. This voltmeter gives the value of potential difference across the terminal of the battery. So voltage drop across the resistance R is capital V, which is equal to I into R. Consider this as my equation 1. Here I is current, R is known resistance. Due to this internal resistance, this voltage less than the EMF of the cell. Then how do you write the equation? That is V plus IR is equal to Xi. For example, the EMF value of this cell is 10 volt. Voltmeter shows 8 volt. Then remaining 2 volts drops across this resistor. That is why I said due to this internal resistance, V is lesser than the EMF of the cell. This capital V is lesser than the EMF of the cell due to the internal resistance R. So V plus IR. Here V is 8 volt. Voltage drop across this R is 2 volt. So V plus IR is equal to our EMF. So V plus IR is equal to Xi. I need this internal resistance R. So IR is equal to Xi minus V. This is my equation 2. Divide equation 2 by equation 1. Here IR is equal to Xi minus V divided by equation 1. IR divided by this V. Cancel this I need R. So R is equal to Xi minus V by V into R. Substitute V, R, Xi value, you can easily calculate internal resistance R. From this equation, we can easily calculate current also. That is V plus IR equal to Xi. Instead of V, substitute this IR. So IR plus IR equal to Xi. Take I outside. R plus R equal to Xi. I need I. So I is equal to Xi by R plus R. Using this formula, we can easily calculate current also. This is for internal resistance. This is for current. So due to this internal resistance, power delivered to the circuit is not equal to the power mentioned in the battery. Power delivered to the battery is denoted by P, that is equal to V into I. You know that V is equal to Xi. According to the first diagram, voltmeter reading is equal to the EMF of the cell. So instead of V, you substitute Xi. So P is equal to I into Xi. This is my equation 3. Substitute Xi value, that is xi is equal to V plus I into R. V plus I into R. So P is equal to I into V plus I into R. This V is nothing but I into R according to equation 1. So I into R plus I into small r. You can get I square R plus I square R. This is my power P. Here this one is power delivered to the circuit. Here power delivered to the internal resistance. For a good battery, it has low internal resistance. So you can easily neglect this term. Finally, you can get P is equal to I square R. What is your conclusion? The entire power is delivered to the circuit only. That is the power delivered to the resistance R. In this class, we discussed about the definition for EMF, that is electromotive force, and internal resistance small r. We derived the formula for power, that is P is equal to I square R. I hope this video is useful to you. If you like my video, please share and subscribe my video. Thank you.